Hi, today we're going to talk about Notes 1-6, which is solving systems of linear equations. This is pretty much like a review of Algebra 1 when you used to solve using the substitution and elimination method. But we're going to introduce a little bit more vocab. So when we solve a system of linear equations, you need to know what a system is and what the solution represents. So a system is pretty much a group of more than two equations. So a system of equations is a group of two or more. You're used to seeing two equations. When we solve two or more equations, well, we know that I can graph this and it's a line. I can graph this and it's a line. So the solution is the point of intersection. Where do the two lines intersect? Where do the two lines meet? So whenever we have two or more lines, they can either have one solution or one point of intersection, which the answer to the system would be the actual point of intersection. If you have a point of intersection, we say that that is called a consistent independent system. So consistent because it has an answer, and independent because, I always try to remember that it's because the two lines are independent of each other. That's how I remember it. Two lines, however, can be on top of each other. Maybe they're the same exact line. But remember, when we solve a system, it means find the points of intersection. Well, if you have a line on top of a line, because it's the same one, then they will intersect at an infinite number of points. And you can't sit there and list them all. So our answer would be infinite solutions. That answer, we consider it to be a consistent dependent answer. So consistent means you get a point of intersection. Either you get one or you get infinitely many. I always remember that independent is when the two lines are independent of each other, so you just get one point of intersection. And the way that I remember dependent is that the two lines depend on each other because they're the exact same one. So infinite solutions, we say that that is a consistent dependent system. And the last one is, what if the lines are parallel and they don't intersect at all? Remember, when we solve, we are asking, what is the point of intersection? But in this case, if they have none, you would say no solution. You don't get to say undefined. Undefined is whenever we have a number divided by 0. That's undefined. We don't care about undefined. So in this case, when you have parallel lines, we get no solution. And if we have no solution, we say that that system is inconsistent. So again, I always remember, consistent means you get points of intersection. Inconsistent means you don't have a point of intersection. The lines must be parallel. Independent is when the two lines are independent of each other and therefore you get one solution. Dependent is when the lines depend on each other because they're the exact same one, so you get infinite solutions. And again, inconsistent means no solution. So when I ask you to solve, the answers are going to be the point, infinite solutions, or no solution. If I ask you what is the type of system, then you would say, oh, this is a consistent independent, consistent dependent, or inconsistent. So I know, lots of vocab. So let's go over the first one. In Algebra 1, you learned that there is a substitution method and an elimination method. In this system, I'm going to go ahead and choose substitution. The goal of substitution method is to substitute one letter, one variable, with the other one, so you only have one equation with one variable. So right now, I can't solve for x when there's a y involved, and I can't solve for y when there's an x involved. So my goal is going to be to substitute so that I get one equation with one variable. With substitution, you always want to get one variable by itself. Here, y is already by itself. So I'm going to go ahead and use this, and you can imagine like the teacher's going to leave, and this is the substitute. So in the first equation, everyone's going to stay except for the teacher who's going to leave, and that's going to be the substitute. So when I rewrite the first equation, I'm going to say negative 6x plus 5, but y is going to be replaced with 3x plus 7. Because I know that y is equal to 3x plus 7. But I'm going to continue on the first equation. Negative 6x plus 5 times y, which is 3x plus 7, equals negative 1. And what substitution does is I've replaced y with x, so now I could solve for x. So now this is going to be negative 6x, and if I distribute, we get this. We can combine like terms. Oh, I think this is 9. We can subtract 35. And then we can divide both sides by 9. But in this case, that means that if I'm solving the system, I'm looking for the point of intersection. So there must be, I mean, this is a line, the other one's a line. I've got an x value, but I'm not done. My answer needs to be the point of intersection. So I have the x, now I'm looking for the y. So to find y, I'm going to just replace it into either the first or the second equation. It doesn't matter. They should both give you the same y. So I'm going to plug it into the second equation. Sorry, substitute it into the second equation. So now it'll be y equals 3 times negative 4 plus 7. Again, once I get x equals negative 4, I'm going to substitute it into this equation to solve for y. So that's negative 12 plus 7, which is negative 5. So this is the solution to this system. And in this case, this would be considered a consistent independent. So if I had to name it, this would be a consistent independent. They intersect at one point. All right. I can also verify. So for example, this is in standard form. So the slope of this line is going to be negative a over b, which is 6 over 5. And the slope of this line is going to be 3. So knowing that the slope is not the same, I know that they're not parallel and they're not the same line. So therefore, I better get one solution. We could do something similar for number 2 before I begin. I could just verify. So my slope here is going to be negative a over b. So negative a is 3 over b. And that's negative 1/2. And the slope of the second line is going to be negative a over b, which is 1/2. They're not perpendicular and they are not parallel. So, but I mean, all I care about is parallel or the same line. So because the slopes are not the same, I expect to get one solution. So in elimination method, you use it whenever things already line up. And the goal is to eliminate one of the variables, get rid of them. Because then if I can get rid of the x's, then I can only deal with y's. This is also called the linear combination or the addition method because we end up adding the two equations together. So in this one, I already had a variable by itself. But here, getting y by itself means getting fractions. If I get y by itself, I have to get fractions. You could get, use substitution, but it's important that you're good at both. So in elimination, I'm trying to get rid of a variable. And I'm going to try to get rid of the y's. You could have also chosen to get rid of the x's, but I like the y's because they have a negative and a positive. So I'm going to go ahead and multiply the first equation by some number and the second equation by another number so that these two become the same number and negative and a positive can cancel out. So I know that 6 and 8, I think their common multiple would be 24. So to get 6 to become negative 24, I have to multiply this by 4. And to get 8 to become positive 24, I have to multiply it by 3. So if I want to keep the original equation, except, an equivalent equation, except where the numbers are bigger or smaller, you have to multiply everything by the same number. So if I distribute, I get this. And if I distribute on the bottom equation, okay. So at this point, now I can go ahead and eliminate. Notice that this top equation is equivalent to that one, and the bottom equation is still equivalent. They're just looking a little bit different, but they're still the same equation. The most common mistake people make is they cancel it, and they forget that when you're canceling, you're technically subtracting because that is what elimination method does. You are subtracting. So negative 12 plus 12 is 0. Negative 24 plus 24 is 0. I don't have to write 0. And then people would like to cancel this off too, but they're not opposite signs. When I combine negative 12 plus negative 12, I get negative 24x. Okay? At this point, I can go ahead and divide both sides by negative 24, and I would just get x equals 0. And notice, I better get an answer because these were not parallel. So I better get an x and I better get a y. If I accidentally cancel out both and I end up with something that doesn't make sense, check yourself. Were you supposed to get one solution? And if not, then maybe it's one of these two. Okay, so if I replace x with 0, I can replace it into the top or the bottom equation. So I'm going to go with the top. Negative 3 times 0 minus 6y equals negative 3. Okay, so that's just 0. So negative 6y equals negative 3, which means y is 1/2. So my answer is 0, 1/2. And if I had to name it, this would be considered a consistent independent system. So you might be thinking, what will it look like for me to get no solution? If I solve algebraically, no solution means that everything cancels and you end up with something that is false. Like maybe the entire left side becomes 0 and the entire right side becomes 1. Does 0 equal to 1? No. So it would be no solution. So that's what algebraically would look like for no solution. Or if you can spot that they're parallel, you could be like, oh, they're parallel lines, you know? But just because they have the same slope doesn't necessarily mean they're parallel. Because if you have the same line, they have the same slope and the same y-intercept. So for it to be infinite solutions, algebraically, you would get something like 0 equals 0, where that's a statement that is always true. Or 1 equals 1, where it's a statement that is always true. So maybe everything becomes 1 equals 1, or everything becomes 0 equals 0. There's no variables, and you just get a true statement that is always true, infinite solutions. No solution means everything cancels, or almost cancels, but you end up with like 0 equals 1, which is not true, no solution. All right, so now I want you guys to go ahead and think about, would you use elimination or substitution? Okay, hopefully you chose elimination. Now you're going to go ahead and try this. So for this one, I'm going to multiply the top equation by negative 5, and I'm going to multiply the bottom equation by 2. Notice that here, the signs are the same on both. So one of them needs to be positive, one of them needs to be negative, so that when I add vertically, things cancel out. So maybe instead of getting rid of the x's, you chose to get rid of the y's. In which case, maybe you multiply the top by 3, the bottom by negative 4, or top by negative 3, bottom by negative 4. It's fine. But notice that I'm labeling everything as I go. So whoever is reading my work knows exactly how I manipulated the original. You want to make sure that you stay organized because it's going to get tougher. When I distribute, I get 10x minus 20y equals 50. And again, maybe yours looks different, and that's okay. Then for this one, we're going to get negative 10x plus 6y equals 6. Okay. At this point, notice that the negative 10 and the 10 will cancel. So all I'm doing is I'm combining like terms. That becomes 0. This becomes negative 14y. And on this side, if I add, I get 56. So when I divide both sides by negative 14, we get negative 4. But again, that means I need to substitute it back in to solve for x. So that's negative 5x plus 3 times something equals 3. I'm replacing it into the second equation just because, I don't know, I like it. But you could have replaced it into the first. And so when you're done, you get negative 4 and negative 3. Another common mistake people make is they'll label it negative 4 comma negative 3. But always label it with x first and y second. If it's using different letters than x and y, always label it in alphabetical order. So whatever shows up alphabetically first. All right, last one. We're going to solve the system. But in this case, it's looking weird. It's not looking the same. So the first thing I may want to do is I notice that it has v's on the denominator. So I'm going to do some replacing first. I'm going to let a different letter, not u or v, like x, be 1 over u, and v, y, be 1 over v. And you're going to go ahead and box this, memorize, like, no, don't memorize it, but box it. because these are going to be our conversions at the end. If you don't do this, you will most likely get marked off. You have to say what your substitution is going to be. All right, so at this point, I'm going to go ahead and realize that the first equation, it's the same thing as 6 times 1 over u, and this is the same as 5 times 1 over v. So using my conversions, I can replace this with x and that with y. So I'm going to write it again. 6x plus 5y equals 1. And now my heart feels a little better. For the bottom equation, instead of 3 over u, it's 3 times 1 over u, which is 3x, minus 10y equals 3. Another common mistake people make is that they replace 1 over u with u and 1 over v with v. You have to pick a different letter, a different variable. All right, at this point, I want to get rid of the y's because they're already positive, negative. So I'm going to multiply the top equation by 2. And I'm going to say this becomes 12x plus 10y equals 2. And when I do so, elimination gets rid of that one. And when I divide both sides by 15, I don't get 3, I get 1/3. Okay? Once I solve for x, I can replace it. And maybe I'll replace it into the second equation. And I need to show my work somewhere. Notice that this is still organized. Anyone who reads this can still tell what I'm doing. Then you're going to get negative 1/5. At this point, people say, oh, the answer is 1/3, negative 1/5. However, the original problem was not asking for u and v. I mean, for x and y. It was not asking for what does x equal and what does y equal. It was asking for u and v. Hang on, that's fine. My cat, sorry. All right. So once I solve for x, I have to use my conversions to turn them back into u's and v's, because the system is pretty much the point of intersection in relation to u and v. Well, I know that x is 1 over u. And then if I cross multiply, or I could just do by comparison, I know that u is equal to 3. Similarly, y is the same thing as 1 over v. And maybe instead of putting the negative on top, I put it on the bottom. So now by comparison, I can get that v equals negative 5. Or you could cross multiply, and then you could solve. But my answer needs to be as a point of intersection. So the point would be in alphabetical order, 3, negative 5. All right. Hope this helps. Have a good one, guys.